All right, this is Coach Williams, and we are going to go over 7.1 notes today. And on these notes, we're going to have a lot of vocabulary. And so the very beginning of this is going to be vocabulary words that we'll have to try to write down. Once we get through the gist of this, the vocabulary terms, and go through a few examples, the examples themselves for chapter 7.1 are really easy to go through, and that'll go pretty fast. We're going to work with nomials. You're going to see nomial on a lot of these here. We're going to talk about monomials or monomials. You have polynomials, you have binomials, trinomials, etc., etc. And we'll break down the meanings of those as we move along. So let's get started on our vocabulary, and then, like I said, once we get into the examples, it's going to move along pretty fast. So the first thing we want to talk about is what is monomial. Mono means one. And so a monomial is going to be a number or variable or product of a number and one or more variables with whole number exponents. With whole number exponents. Okay, so with whole number exponents, we're dealing with exponents that are whole numbers, not like we did in Chapter 6 where we might have had the 1/2 and so on and so forth. So we're dealing with whole number exponents. And some examples of a monomial would be like the number 10, or maybe the variable a. That's a monomial. And an example of a product of a number in one or more variables might be 2x squared. That's a product of 2 and 2 x's, so that is 2x squared. That's a monomial. Then we'll have maybe a negative 3a squared b cubed. Again, this is a monomial. It's a product. It's like a term. We're going to see that word in a minute here, a term. It's one term, but it's a product of individual items, one being a number, and then you got a variable here, another variable there. And then another example might be, because we can have non-whole number coefficients, 1/2 xy, 1/2 just being our number, quote-unquote number. Okay, so those are examples of monomials. The degree of a monomial, let me change colors here so we don't get these mixed up, is the sum, it's the sum of the exponents of the variables. Okay, so the sum of the exponents of the variables, and let's look at some of this together. If I'm looking at the first one that we gave you an example of, the degree of 10. What's the degree of 10? Well, first, are there any variables in 10? No, there's no variables with 10. You could say that if 10 had a variable, let's say it had an x variable, but raised to the 0 power, what is anything raised to the 0 power? That's equal to 1, right? And 10 times 1 is just 10. So what would the degree of this be? What's that degree right there? No, it's a 0. Somebody said it was a 1. The degree of x is 0, which makes it a 1, which means there are no variables with this. I mean, if you just think about it, there's no variables in 10. It's just a number 10. So the degree of the variables would be 0. What about a? The degree of the variable a is what? A to the what power is a? A to the first power is a. So what is the degree? 1. Does everybody see that? It's a to the first power. There's one variable here. So the degree of this monomial is 1. What about 2x squared? What's going to be the degree of 2x squared? And I'm getting signs here. It's 2, and it is 2. It's 2 because we have 2 x's. It's the degree or the number of variables. If you think about it, I have 2 times x times x. So how many variables do I have? Well, I have 2 x's multiplied times each other in this product. So the degree is 2. And then what if we had the example of negative 3a squared b cubed? What would the degree of that be if we counted up all of those? And once again, I'm getting 5 in the crowd here, and that is correct. We have 2 a's, we have 3 b's in this product, and so the degree of this monomial is 5. Okay? Not too difficult once you kind of get the hang of how to count up, those, basically the exponents of variables. Okay, polynomial. What is a polynomial? What does poly mean? What is okay, I'm getting more than one. It means many. Poly means many. So a polynomial is something that has many nomials, we'll say, has many terms in it. In this case here, a polynomial is a monomial. Let me write correctly here. A monomial or sum of monomials. And again, like I mentioned, we're going to come to this word here, terms. So it's really the number of terms in the expression that determines how many of the many we have, or the poly we have. In this case here, for this example, we'll say 2x cubed plus 3xy minus 4y squared. How many terms do we have here? If we're looking at this in the sense of terms, that's a term. 2x cubed is a term. 3xy is a term, and negative 4y squared is a term. So how many terms do we have? We have 3 terms. And we could circle those just so you kind of see what we're talking about. That's a term, and that's a term. Or that's a monomial. Remember, monomial is a number, a variable, or a product of a number and one or more variables. Here's another product of a number and 2 different variables, and here's a product of a number and 2 of the same variables. So that's a monomial, that's a monomial, that's a monomial. We have 3 terms in this polynomial here. Okay? All right. Binomial. What does bi mean? Bi means 2. Okay? So we're going to have 2 monomials, right? So we'll have 2 of those. So this just means this is a polynomial. A polynomial with 2 terms. Okay, example of that would be 2x squared minus 4y. There are 2 terms. That is a binomial. And obviously a trinomial is going to have how many? 3. Yes. So a trinomial is going to be a polynomial with 3 terms. And an example of that would be something like 2x cubed plus 3xy minus 4y squared. We may say something like that as an example of a trinomial. Okay, now we get into something that is important, especially for our practices that we're fixing to see here, our practice problems, and that is the degree of a polynomial. What is the degree of a polynomial? Well, the degree of a polynomial is the greatest degree of its terms. It's the greatest degree of its terms. So if you're going to look at all the terms here, let's give an example. 3x cubed y minus 2x squared y cubed minus 2x plus 4. So we've got this polynomial. Well, the degree of this polynomial is going to be the greatest degree of its terms. So if you're looking at the terms here, what's the degree of this term right here? Remember, it's the sum of the exponents of the variables in this one right here. What's the degree of the first one? The degree of this first one is what? 3, and y has a 1, so the degree of that is 4. The degree of this one, this term right here, we have two different variables. There's 2 x's multiplied and there's 3 y's multiplied, so 2 plus 3 is 5. Here we only have 1 degree, and there we have 0, okay, according to our definition of degrees of polynomials. Of monomials here. So, what is the degree of this polynomial? The greatest degree of its terms. It's going to be equal to what? 5. Okay, 5 is the highest degree we have. We have an x squared and a y cubed. So basically what we're doing is we're just adding the exponents of the variables together to get the degree of the polynomial. All right, so standard form. Standard form, exponents decrease from left to right. Okay, so the way you would write, certain expressions, you're going to put them decreasing by their exponents from left to right. So an example that would be like 3x cubed plus 5x squared minus 2x plus 4. If you'll notice, the terms, the x terms here, are decreasing by their exponents from left to right. We've got a 3, a 2, a 1, and then basically a 0. Okay, another example, if you had more than one variable in your expression, or in your polynomial, 3a cubed b minus 4a squared b squared plus ab. Okay, well, if you look here, you'll notice the highest, well, actually, if you look at this term and this term, they both are the degree of 4, because you have 3 and 1 here. You have 2 and 2 there, which is both equal 4. But I have an a cubed, and so a cubed takes precedence here over an a squared. So in this case, the standard form here with mixed variables, we have a cubed b minus 4a squared b squared plus ab. 3a cubed b minus 4a squared b squared plus ab. And that would be how you would write this in standard form. Okay? All right, now, leading coefficient, you're going to see this abbreviated as LC here in a minute. But a leading coefficient is the coefficient of the first term when written in standard form. And that's important. We need to know what the leading coefficient is in some cases. And so to find that, we look at the leading coefficient, or the first term, the coefficient of the first term, when we get it into standard form. As an example of that, we may have 3x cubed plus 5x squared minus 2x plus 4. And the LC, or the leading coefficient, is the coefficient of the first term, and this is in standard form. We're decreasing by exponents, 3, 2, 1, 0. So the leading coefficient here is a 3. It's the number in front of that x, the coefficient in front of x, on the first term in standard form. Alright, so now, this just kind of recaps everything we just said. Polynomial is a monomial or sum of monomials. Each monomial is called a term of the polynomial. Polynomial with 2 terms is binomial. 3 terms is trinomial. Here's 2 examples of that. Here you have leading coefficient. Example of that is that number in front of the leading term variable there. And then your last term that doesn't have any variable is going to be your constant term. Okay, let's flip the page and look at some examples. And for the extra practice here, we're going to find out the degree of monomial here. So on the first one, remember we're looking for how many variables there actually are. Okay, how many variables there actually are in our term or monomial here. So on the first one, what is the degree of the monomial? We have an s to the first power. Basically, what is the degree of the first term? It's just simply 1, right? It's the degree of, or the number of variables that we have in our term. What about number 2? What is number 2? 1. 1. Again, we have w to the first power. We have 1 variable, and so we have 1. What about number 3? 0. There are no variables here. If there were, they're raised to the 0 power, and they become a 1, so they disappear. So we have 0 as the degree of number 3. What about number 4? 3. We've got a to the first, b to the first, and c to the first, and we add those up, and we have 3 degrees. What about number 5? We have 2 and 1, so this one is also 3. If you think about it, break it down, you have, how many variables do you have? We have 2 x's and 1 y, so that makes 3 total variables. Alright, number 6. We have 2, 3, and 1, so there's 6. Number 7, we have 1 and 3, so there's 4 there. And then number 8, 0, because there are no variables. Okay, the next part here, 9 through 12, we've got to squeeze a little information here. They want to know several things. They want to know, they want us to write it in standard form, so we have to change the order, get it in the right order. They want us to identify the degree of the, and they want us to identify the leading coefficient of the polynomial, and then classify it by the number of terms. Okay, so let's look at this together. First of all, what would be my first term if I'm rewriting this in standard form? What is the first term in standard form? It's going to be 3x squared, 3x to the second power there, so we'll have 3x squared because it's the highest exponent of the terms that we have here. So now 3x squared is gone. The next term would be the x, and then the final term would be the constant of 5. All right, now that's in standard form. What is the degree of this polynomial? Remember, it's the highest degree in a term. It's the highest, it's the term with the highest degree. Nope, the degree is going to be 2 because this term here has an exponent of 2, that one has an exponent of 1, that has an exponent of 0. So the highest or the greatest degree of its terms is 3x squared. So 2 is my term. Number 10, I'm sorry. Square root of 5 times y. How would you rewrite that? Can you rewrite that? No, it's just the square root of 5 times y. So we're going to have the square root of 5 times y. Nothing changes as far as the form goes. The degree here is going to be... Oh, I didn't finish the last part. I'm sorry. We told the degree of this one. What was my leading coefficient on number 9? I forgot to write that down. Leading coefficient is 3. It's the number in front of the first term. And then this is how many terms altogether? Is this a binomial, monomial, trinomial? What is this? Trinomial. There's 3 terms. So this is a trinomial. Meant to finish that out there. Alright, let's finish number 10 now. We've got the degree of what? Y to the what power? It's the only term in here, so it's y to the what power? 1. So our degree is 1. Our leading coefficient is the square root of 5. It's the number, the coefficient of y, because it's our only term, and it's in the front. So it is the square root of 5, and then it is a monomial because there's only one term here. Okay, on to number 11. What is going to be the first term we see if we write this in standard form? It's going to be the 6x to the 8th plus 3x to the 5th. That's the standard form. From left to right, we're decreasing in exponents. Our exponents are decreasing from left to right. The degree of this polynomial is 8, because the highest or the greatest term we have, the greatest degree of terms is 8. The leading coefficient is 6. It's the one in front of the first term in standard form, so it's 6. And this is what? What classification? It is a binomial because it has 2 terms. All right, number 12. Number 12. How would I start this one out? Would it be 2f? F squared or f to the 4th power? We're looking for the term with the greatest degree. So f to the 4th would be my greatest degree term that I have. What's the next one? F squared. And we're going to add f squared. It's positive. And then, of course, that gets rid of that one and that one. And our last one is minus 2f. So in standard form, I'm decreasing by exponents as I move along. All right. What is the degree? Well, it's the highest, degree of the terms, and I have a 4, so 4 is the highest one I have. This is 4, 2, and 1, so 4 is the degree. The leading coefficient, 1. Okay, in front of this right here is a 1. Okay, it's 1f, and so the leading coefficient is a 1. All right, and then this is what classification of polynomial. It's 3 terms, so it's a trinomial. And that's not too difficult. Let's move on to the next section. We're going to take these, and we're 13 through 16, and we're going to combine like terms, basically. And we're using sum, so everything is dealing with addition. When we deal with addition and parentheses, then nothing should change about the sign of the terms inside the parentheses. So in theory, because there's an addition sign, we could actually do away with the parentheses and take the terms as they are. Meaning that we can just combine like terms without having to worry about changing any signs. That being the case, we can take our x terms and our integers and we can put those together if we're going to write this in standard form, what is the first term that we're going to have on number 13? What would we start with? We start with the x terms, or we start with the constant terms? If we're writing this in standard form, we're going to start with the x terms. And so we're going to take 6x, positive 6x, and negative 4x, and we're going to combine those together. And 6x minus 4x, or plus a negative 4x, is going to give us a positive 2x. Then we're going to take this positive 9 and this negative 14, and we're going to put those together. And when we do that, we get a negative 5. And so in standard form, after we combine like terms, 2x minus 5 should be the answer for number 13. Once again, on number 14, we've got the addition sign here, so we can just eliminate the parentheses and not have to worry about any sign changes. That being said, again, what's the first term that we would start combining? The 7a and the negative 3a. So we have a positive 7a, a negative 3a there. We're going to combine those terms together. We're going to get a positive 4a. Then I've got this positive 5 and negative 2. I'll combine those together. I'm going to get a positive 3. So in standard form, with everything added together, I get 4a plus 3. Okay, number 15 and 16, we're going to do much the same way. Because they're addition signs, I can get rid of my parentheses. I don't need those. I can just deal with the signs that are given. And I'm going to add, and what am I going to do here on this first one? Because I have multiple terms now. What are we going to... We're going to start with the bigger one, he says, here in the classroom. What defines which one's the bigger one? Is it the exponent or the coefficient that makes it the bigger? It's the exponent. And so we're going to go with this negative x squared and a positive x squared as our first term. When I combine those, though, what happens? X squared minus x squared is? It's actually 0. So that just goes away. So now I go to the next term in order in my standard form. And the next term is going to be what? Yep, the 3x plus the 6x. So I'm going to add those together. I'm going to get 9x. And then the last thing I will put in here is my constant term, which is the positive 5 and the negative 4. And so I'll have a plus 1 to finish this one off. Okay, on number 16, again, we've got a positive sign. We can get rid of our parentheses and take the signs as they are. What's the first term that we will have to work with here? Somebody mentioned 2t squared and t squared, but I think I have a degree higher than squared. I've got a 3t cubed and a 2t cubed. So those are the first one, a positive 3t cubed and a negative 2t cubed. And when I combine those, I end up with just 1t cubed or just t cubed. Then the next thing I will do is go to the next degree. If it's available, and it is, I've got a t squared and a 2t squared, and I'm going to add those together. This is a positive t squared if I bring the sign with it there. So I have t squared and 2t squared, which should give me 3t squared. And then I'm only left with one of the next degree, and that's the 7t. There's no other t to the first power terms, and so I'll just add 7t. That one's taken care of, and then the only constant I have in this expression is a negative 3. And so rewritten in standard form, combining like terms, this is going to be t cubed plus 3t squared plus 7t minus 3. All right, on the next section, we're actually going to be finding the differences So we will have to do something about those signs in the parentheses because we have a negative in front of this second part of the expression. So number 17 now, when we have the negative, that negative simply changes the sign of everything in the parentheses. So we're going to have rewritten before we combine everything. G minus 4, that stays the same. But instead of positive 3g, I have a negative 3g. Instead of a negative 6, I have a negative 6, which makes it a positive 6. And so that is rewritten, taking care of the parentheses and the negative sign. Now I can combine like terms and put it into standard form. Again, this negative sign is just being distributed into the parentheses, and all it does is change the sign of the terms within the parentheses. Okay, so that being said, now let's combine like terms. What term will come first here? The G terms or the 4 and the 6 term? Should be the G terms. And so we've got a, let's change colors. So we've got a positive G and a negative 3G. And when I put those together, I get a negative 2G. Alright, so negative 2G. Whenever I combine this negative 4 and the positive 6, I get a positive 2, and that's all the terms, and that is standard form, negative 2G plus 2. Okay, moving on to number 18. Again, this negative sign is going to have to be distributed into the parentheses, and so it just changes the sign of the terms within. So we have negative 5h minus 2, and then we have a negative 7h because it was positive. We have a positive 6, so we have to change the sign on that one. So this would be a negative 6. And then now I can combine like terms and put it in standard form. Which terms do I combine first? The h terms. So we're going to have a negative 5h and negative 7h. We're going to combine those, and we're going to end up with negative 12h. I'm going to have this negative 2 and negative 6 terms. I can combine those, and I end up with a negative 8. So the simplified standard form here is going to be negative 12h minus 8. Alright, on to our last two examples, and we are done with our notes part of the day. Here again, I'm going to have to distribute this negative sign in to all of my terms. Okay, so that negative sign is going to change my negative 3x squared. A negative 3x squared makes it a positive 3x squared. A negative x is going to be a positive x, and a negative 8 is going to be a positive 8. So it just changed all the negatives to positive. Now I can combine like terms and put it in standard form. What will be the first term in standard form for this polynomial? What should be the first term if we put it in standard form? The x squareds. Yes, we have a negative x squared and we have a positive 3x squared. So when we combine those together, I should end up with 2x squared. 3 minus the 1 is going to be 2x squared. The next term, well, there's only one x term left, so it has to come next. And then the last thing we have is our constants, and we can combine those. 8 plus a negative 5, or 8 minus 5, it's going to be a positive 3. And so that is your standard form on number 19. Last one on number 20. Again, we will take the negative sign, we'll distribute it into the parentheses, and rewritten, we'll have k squared plus 6k cubed minus 4 minus 5k cubed, because it changes from positive to negative, minus 7k, but plus 3k squared. Minus a negative is plus. And now I can combine these. What will be my first terms in standard form? The k squared is not as high as the k cubed. So we're going to have 6k cubed positive, and a negative 5k cubed. We put those together, we get a 1k cubed, or just simply k cubed. The next term, we can use the squares. So now I've got positive 3k squared and a k squared, and when I add those together, I get a positive 4k squared. Okay? And then I have only one k term left. So minus 7k. And then the only constant we have in here is the minus 4. So in standard form, we should end up with k cubed plus 4k squared minus 7k minus 4. And that's your answer for number 20. All right, I hope this has helped you guys out, getting some information for 7.1 on monomials, polynomials, the classifications of polynomials, degrees of polynomials, and then also writing these in standard form. You should have a pretty good idea of what to do on your practices now. So we will see you guys next time. You have a great day.